Hello, this is our class for Thursday, April 23rd. We're going to be talking about section 9.2. It's a paired t-test. This is a test for comparing the means in two groups of data. So we've already done a two-mean t-test where we split our sample into two groups. We compare the mean in one group to the mean in another group. This is going to be a different way of comparing two groups. And before I jump into the first example, we're going to have one example based off of a new data set that should be linked near the link to my notes and video links on my website. So one of them is weight loss data. So there's two sets of data that we're going to use today. There's weight loss data and the old exam data that we used from a few days ago. Okay, so the whole point of the paired t-test is that unlike our previous situations where we were comparing two groups, now the two groups are somehow connected together. They're not independent anymore. So like when you're doing the project and you have the temperatures from like the 1950s and the temperatures from the 2010s, there's sort of a bit of an association with them depending on the time of the year. And I guess you could think of that, but basically like it's just temperatures from one time and temperatures from a different time. If you were to split a group of subjects into two groups based on, like which people got the blue set of materials and which people got the red set of materials, and then you compared their achievements on some kind of measurement, there's not really anything connecting the people in one group to the people in the other group. The paired t-test is specifically for situations where in each group there is a number that goes with a number from the other group. So a perfect example is the exam data that we looked at a few days ago, where like I actually had exam scores, like 4 different exam scores for each student if they took all 4 exams. So instead of just saying, here's a bunch of scores from the first exam and here's a bunch of scores from the second exam, and they have nothing to do with each other, we acknowledge the fact that actually we have 2 exam scores from each student and we can connect them together. We could say, instead of just saying comparing the mean on the first exam to the mean on the second exam, we could see how much each student's exam score changed going from the first to the second exam, and then compare those. So my other example is weight loss data. So in the weight loss data, we're going to have before and after. Like weights basically. So each person has 2 numbers, a before the weight loss program number and an after the weight loss program number. And we want to know, does this weight loss program work? Are the weights afterwards lower than the weights before? And is it at a statistically significant difference? We could just take the mean of all the weights in before and the mean of all the weights after and compare them using a 2-sample t-test. But it would make more sense to say for each person, how did that person's weight change? So sort of like take their 2 numbers, do a subtraction, and find the difference between their 2 numbers, and then compare those changes for each of the individuals in the weight loss program. And so that's basically how the paired t-test works. So if you haven't done it already, download the weight loss comma separated value file from my website, and we're going to load that into Minitab and run a bunch of tests on it. And so just before I go into Minitab, and I think I'm going to do Minitab in a separate video because I've been talking for a while, we're going to do a bunch of different stuff. We're going to find the mean and a 95% confidence interval for the before and after. And then we're going to do the old comparing two groups version. So the 2 sample T for before and after. And actually, there's 2 sets of before and afters. Like you could think of it as 2 different weight loss programs. So we're going to do, so there's really 4 different sets of data. There's a before and after for one weight loss program and a before and after for a second weight loss program. And I've made up this data. Like I set it up specifically just to point out the difference between the 2 sample T and the paired T. So, so we're going to find a mean and a confidence interval for before and after, and redo that for the second version of before and after. And then we're going to do a 2 sample T for each set of before and after. And then after we do that, we're going to do the paired T test for before and after. Okay, so I'm going to stop this video and we'll flip over to Minitab and upload the data in the next video.